only has 68 sides. So this is the last one had 185. Oh, yeah.
So I'll just list some properties of logs. And this is in Dino. B time log base. Nope. B to the power of log base B of x. What does that equal? Or is that too small? Yeah. Okay. Yep. So you guys can sign in if you don't, or if you just came. 2. Log base B of B is 1. 3. What was the red light? Log of log base B of x to the n power is equal to what?
And log bx.
Yep. So this comes out. And this is for x is greater than 0. Just since.
You don't have to worry about writing that.
Log base B of m times n is equal to what? And when they're divided, and log of E is equal to natural log. Essentially, this unit is manipulating this to get solutions. And I'll just erase this now. Derivative of natural log of x is what? 1 over x plus c. No. You don't need plus c because it's derivative. But
I was very wrong.
derivative of natural log of u is equal to 1 over u du dx. The integral of du or du divided by u is equal to the natural log of the absolute value of u plus c. You guys need to remember the absolute value signs. Derivative of u d over dx of e to the u of x. that's just e to the u of x times du dx. So if I had, what's the derivative of e to the x? E to the x. Do you guys get that? Because you have e to the x, right? So this is equal to e to the x times the derivative of x, which is 1. So this is equal to 1. So this is equal to e to the x times 1. So if I had a 2 here, you would multiply this by a 2, so it would be 2 e to the x. And then you have x squared, you keep on going like that. Log of base a, log of x, is equal to natural log of x over natural log of a. All these properties you'll use to solve, like, say you have natural log of 6.75. You can't just automatically know that, but you can use these identities or properties to get an answer. The integral of a to the u times du is equal to 1 over the natural log of a times a to the u plus c. Not in this. When you have du over u, I think so. Yeah. What? Yeah, I think so. The rest don't. Yeah.
Is A a number, or what is A in this case? It's like an A raised to a function.
Yeah.
So like 2dx.
And then this would be dx. The derivative of log base a to u do I want to show you the whole proof of it or just give you guys the... So I'll just show you guys. Derivative of, so this would be an example of how we use a property. Derivative of log base a of u, that's equal to the derivative of the natural log of u over the natural log of a. And this u would be like a function. Since this is just a constant that can come out, so 1 over the natural log of a times the derivative of the natural log of u, which is 1 over u du dx. So if you had to take a derivative of something that's a function with any base, this would be the formula. 1 over natural log of a times 1 over u times du dx. And then you'll get enough practice that it'll be like you'll just remember them.
So they wouldn't ask you to take the derivative of like the natural log of a constant, right?
No, because that's a constant. Yeah, that's just 0.
It is
Like derivative of a constant is 0. So you guys, this is objective 1 in class, but so you guys should understand. there is a bunch of memorization, essentially. Don't memorize the methods in class that you guys learn. The method 1 and method 2. Because you guys do need to show your work on the exam. And it's really simple actually to know what's happening. So in this example in class, you let A equal to the natural log of 3, B equal to the natural log of 2. You guys did this in class, right? The very first time you were introduced? Okay, cool. Because these are my notes. I don't take notes when I am in class with you guys. Okay. So if I have the natural log of 3 halves, sorry, I just gave it a little bit. If I have the natural log of 1.5, what can I do to it? I can convert it to natural log of 3 halves. Then I use the property saying that this is the natural log of 3 minus the natural log of 2. So this is essentially A minus B. Because when they're divided inside, you can subtract them by making 2 separate natural logs. Yeah. Let's do a harder one. Natural log of 12. Can you guys see a step that I can do? Natural log of 3 times 4. And then I can separate them, so it's natural log of 3 plus, but you can simplify it even more by making this a 2 squared, so that the squared part comes out. So this is 3, or A, plus 2B. Do you guys see how that happened? I'm not going to go over taking, so the derivative of natural log is what? Natural log of u, so times, yeah. I said that before though. Or, okay, I'll go over it. So if you have a problem like that, the derivative of the natural log of x squared plus 2x, you just do 1 over x squared plus 2x times the derivative of the inside, which is 2x plus 2. And then you can sort of simplify it even more. If I have the derivative of natural log of 2x times the square root of x squared plus 1, what do you guys think would be the first step? What? First thing you guys should do is separate it. Okay? that would make it really easier than trying to do 1 over all of this and then do a triple product rule. So then this would be the derivative of the natural log of 2 plus the natural log of x plus the natural log of x squared plus 1 to the 1/2. Now I put it to the 1/2 power because we can use the other property we learned and bring it outside too. So then once you do all of that, you can get an answer. Okay? So it's just using the identities or properties that we learned to manipulate it so that they're easier to solve.
Did you say that the derivative of the natural log of the constant is 0?
Yeah.
So L2 is 0?
Yeah, this is going to go to 0. Now, wait, let me see. Okay. This one is good one. Are you guys good with this? Is the natural log of x and its quantity cubed equal to the natural log of x cubed?
No.
These are not equal. Okay? So first, let's just take a derivative of this. Okay? Before you take a derivative, always try to simplify the inside. This 3 can come out. Okay? So then this will be equal to 3 times the derivative of the natural log of x. Okay? And that would just be 3 over x. If we're to do the derivative of this, what famous rule do we have to use? The chain rule. Okay? First, we take the derivative of the whole thing, which would be 3 times the natural log of x. Okay? X squared. This whole thing squared. Times the derivative of the inside, which now is just the natural log of x. And then the derivative of that is just 1 over x. So this is 3 over x times the natural log of x, and that quantity is squared. Do you guys see the difference in that? So the natural log of cosine of x, what would that be? So the final answer would be negative tangent of x, because it's sine over cosine. Yeah. Do you guys all see that? Or no? Someone send them. I'll just rewrite. So you have the inside cosine of x. So we have cosine of x in the bottom. The derivative of cosine is negative sine. but that goes on top, so this is negative tangent. Okay. And don't forget your inverse properties. What's the inverse derivative of the inverse tangent of x? Du dx. Okay. Yeah, I'm getting there. So you guys are good with these properties. Okay. Moving on. So just a quick one. Y is equal to 10 to the x. What would y prime be? I told you guys the rule, right? Didn't I tell you guys the derivative of like a to the x or something? A to the u? Yeah. Do you know? That's the integral. I didn't? No. I showed it. Or did I not? I have it here. 8 natural log of what? Or I'll just rewrite it and
That'd be great.
sorry. So looking at that rule, what would y prime be?
10 to x natural log of 10.
That's it. Did anyone say that? Okay. No. So this is essentially one thing that you guys will need to do is like remember all of this stuff, memorize it, and then just like use it.
So is that actually
This?
Yeah.
No, this is the answer. Why would it?
The natural log of 10 is 0, right?
No, if I were to take the derivative of this again. So if I took y double prime, then this would be like a constant that I multiply to. So, and then times derivative again. This would be y double prime. What you're talking about is taking the derivative of the natural log. So if I had a problem where I had to do, that's what you're thinking of, right? Yeah, this would be 0. So if I had plus natural log of 10 here or something, then this would be, derivative would be 0. Okay? So yeah, if you were to take the derivative of this again, it would be natural log of 10 quantity squared times 10 to the x. And then that would keep on going up and up and up. Make sure you guys understand that, because that's just very basic. So let's do a tougher one. I'm going to erase this. Y equal to 2 to secant of x. Let me rewrite what I had up there with the formula for it. Okay. Use that to find the derivative. So yeah, 2 secant of x, 2 to the power of secant of x times what? Natural log of 2. Yep. See how that worked? It was just plugging and chugging. Yeah. Did I tell you guys the integral rule? I believe I did. Yeah.
Yeah, that's the one you did.
Okay. Let's do one with that. Can I erase this? Yeah. Let me put up the rule quickly for that. Yeah. How many what? How many properties? There's the 5 basic properties, and then there's like rules for integrals, for taking derivatives and stuff, which you guys just need to memorize. And I'll put up a review of it. So this is a rule for integral again, of a to the u, where a is a constant. 1 over natural log of a times a to the u plus c. So if I have the integral plus of x times 2 to minus x squared dx, what would you do first? So your u is equal to negative x squared. Du is equal to negative 2x. So you have negative 1/2 times the integral of 2 to the negative x squared times negative 2x dx. Okay, so now you have du in there. So that's equal to, you guys want to say the answer? Or I'll just put it. Negative 1/2 times 1 over the natural log of 2 times 2 to the negative x squared plus c. Good. And we're getting to the end of today. Yep. Okay, this one's good. The integral of the log of 16, log base 16 of 3x all over x dx. What would the first thing be? Yep, write it as natural log. 1 over x times the natural log. What would it be? Natural log of what? Of 16. So then this would be a constant. So then we are left with 1 over the natural log of 16 times the integral of the natural log of 3x all over x dx. What should we make our u? Natural log of 3x. What would the derivative of that be? What's the derivative of natural log of 3x? 1. So it'd be, what can I say? 1 over 3x times 3. You will cancel them out to get 1 over x times dx. Yep. So we don't even need to multiply by 3 or anything because we already have 1 over x in there. So this is the integral of essentially u over du. No, sorry, u du. So then it's equal to 1 over the natural log of 16 times those quantities squared over 2. The natural log of 3x quantity squared all over 2. And don't forget to make it very clear that it's the quantity squared. Okay? If I didn't have these parentheses, they would mark it wrong because they'd say that the 3x is squared. Okay? And then what am I forgetting? Plus c. Well, you can simplify this even further. The natural log of 16 is the natural log of 2 to the 4th, right? This 4 can come out, which multiplies it to the 2. So then this would be 8 natural log of 2. This is the natural log of 2 to the 4th. The 4 would come out. 4 times 2 is equal to 8. Can I erase this now? So now we get into the method stuff that you guys learned. Say I have y is equal to x to the x power. Did I tell you guys a way to solve this? I told you guys with a constant raised to a function, like 2 to the x. There isn't a direct way with x to the x. What's the first step? So there are two methods, okay? This is the method that I like. I do the natural log of both sides. So I have the natural log of x to the x power, okay? Using that property with that exponent, it's x times the natural log of x. Then I take the derivative of both sides. So y prime divided by y is equal to the derivative of x times the natural log of x, which is 1 times the natural log of x. Plus what? X divided by x. So then these go away. So y prime is equal to y again, because we bring that to the right side. X to the x times the natural log of and plus 1. So to me, this is the method that I can easily do. Like, it's the one that my mind accepts the easiest. Although the other one isn't hard or anything. So this is the second method. Any questions on this method first?
Is the question probably take the derivative out that you would say like?
Yeah, find y prime. So we have the same thing. The next method uses the property that if I have b to the log base b of x, those cancel out, right? So you're left with x. This method is saying e to the natural log of x. E to the natural log cancels out because natural log is log base e. So that's equal to x. So they rewrite this saying e to the natural log of x to the x exponent. So then this is equal to, we can bring that x down, x natural log of x, everything to log base e, or not log base e, exponent. And then when you do the derivative of it, you do the derivative as of taking a derivative with e to the u power. So this would be e to the x natural log of x times the derivative of u, which is x times 1. Sorry. 1 times the natural log of x plus x over x. You guys get what I'm doing here? The derivative of e to the u is e to the u times du. So that would be the derivative. So y prime is equal to, or we don't even need to do the natural log of x to the x. E to the natural log cancels out, so we're left with x to the x times the natural log of x plus 1. So they bring the same result in the end. So any questions on the two methods? It's again using the same properties that you guys learned on doing the derivative and the properties of logs and stuff. Now, Do you guys think that this was, or do you guys understand this now? Yes? Do you guys want me to repeat it? No? Yeah. And I always just go with the natural log, or multiplying, taking the natural log of both sides. I'm gonna cover more stuff. You guys. At the end of class, or the class that I sat in, we did y is equal to tangent of x to the whole thing to the power of sine of x. Did you guys all do this? Some classes might have not reached it. Do you guys want me to go over it? Okay. So again, the method that I use is the natural log of y is equal to, if I do the natural log, I have sine of x times the natural log of tangent of x. Then I take the derivative of both sides, y prime over y is equal to the derivative of that, which would be the product rule. So sine of x, derivative of that would be 1 over tangent of x times the derivative of tangent of x, which would be secant squared of x. So I'm going to rewrite that as 1 over cosine squared of x plus cosine of x times the natural log of tangent of x. And this is 1 over tangent of x, so we can rewrite this as cosine of x with sine of x divided by sine of x, so that the sines cross out. One of the cosines crosses out, and you're left with secant of x. We can multiply the y to the other side too. So y prime is equal to y times secant of x plus cosine of x times the natural log of tangent of x. And then you can rewrite what y is, and that's the original function. Any questions on this? Are logs easier now? Or whatever? Okay. Can I raise this now? Yes. And this is some stuff that you'll do on Monday. If you guys want to sit, you don't have to. Yeah, you'll learn this on Monday. What? No, you still need to learn more. They'll post. Well, these are problems that I have. I don't believe they were homework. Like this class, they taught 3 days to us. They'll cover homework, but they'll cover more examples. Did that make sense?
I don't know, they've never done that.
Okay. Whatever, you guys will see what's happening. 81 times what? Okay. Log of 3 times 2x. And then you'll be told to simplify this. What do you guys think is the first step? What? Not this time. What is 81 in simpler terms? 3 to the 4th. So we'll have 3 to the 4 times log base 3 of 2x. What is the next step? This is working it backwards essentially. So we have 3 times the log of 3 of 2x quantity to the 4th. What's the next? Those cross out. So you have 2x to the 4th. And that would be see how that worked?
It's not like new material.
Yeah. Different sort of problems. Are you guys good with it? Still writing? Y is equal to log of 16, log of base 16 times 64, or however you would say that. What would the first step be? Or to simplify it. Wait. Okay. Say that again. 16 times 4? Yeah. Or how would you say 16 again? Or if it's fine.
What?
It's fine. Log of 16 times, or log of 16 base of 16 plus log of 16 of what? We can say 4 for now.
4 to the 16.
But then you have to
16 to the 1/2?
16 to the 1/2.
Say that. This is 2.
Okay? So this is equal to 1 plus 1/2 equals to 3/2. You guys see how that works out? I will raise this. Any questions on this? How we got 1/2? So this one, you guys try on your own. 16 to the y power equal to 64. Find y. Try it on your own. This one's pretty different. Or yeah, what? This 3/2. So there's sort of two small ways to do it. One would be natural log of 16 to the y power equals the natural log of 2. Try 16 to what power?
Yeah.
Yeah. Okay. 3/2 comes over. Natural log of 16 y times natural log of 16. Those cross out.
Can you just not write like that at 5? At the second step, can you just not write down that at 5? Why it's 3/2? Because it's the same thing.
Yeah. And then there's one more way to do this. Actually, there's 2 other ways to do it. Okay.
At least 6.
So we have natural log of 16 to the y. We can set that equal to the natural log of 64. Okay. 16, once again, can be split with 4 squared. That quantity, 4 squared, or 4 to the power of 2y, equals to the natural log of 4 to the power of 3. Okay. Then those can cancel out because you can bring them down. 2y is equal to 3, y is equal to 3/2.
Oh, is it? If you choose the 2 to the 4th and then 2 to the 6th.
Yeah, you can do that too. And then there's, oh yeah, if you just directly, the last way, if you just directly do 2 to the 4 y equals 2 to the 6. Is this was the way you were talking about?
Yeah.
Yeah. And then we both have 2 to the 4. What did I do?
You said 4 right.
Yeah.
Yeah. You can do that. 4 also. Y is equal to the first problem that we did. Oh, you were right about it. Y is equal to log of 16 to 64. That problem, you could have split that up and solved it too. So natural log of or 16 or natural log of 64 divided by natural log of 16 equals 3/2. Because you would do it natural log of 2. You guys follow what I said? Yeah. 2 to the 6th. And then that would be 3/2. Good guys? With these? No, with that. I have more problems if we want to go there. No. If I have 1/3 as a base, yeah, it wouldn't make much difference if you just treat it like any other What would the first step in this be? Breaking it up. One third is the same thing as what? 3 to the negative 1. And this one is 3 to the 4th, 81. So this is 4 times natural log of 3, all over negative 1 times the natural log of 3. And the answer is negative 4. And you'll do more problems like this in class. Any questions on all of this? That essentially is the whole unit, better than most units. And then you have some tough integral problems. So do you had a homework problem? Yeah, you want to come?
Solve the line. LF, the natural log of.
Wait. Y is equal to? Or
Just the natural log of parentheses y
minus what?
9, minus natural log of 2. No equals yet. No equals yet. Yeah. There. Now equals x plus natural log of x. So I have to answer it. No, I couldn't figure out how to answer it.
Okay. The thing that you want to do in this case is to isolate y, always, okay? What property can we apply to this right here? Is there a property? Are we trying to find y prime or just y? Y?
I think we need to use it right there.
Oh, yeah.
But like I still got wrong.
Yeah, so you raise everything to the e power. And the thing about it is you have to do everything to 1e. Okay? Let me look at those again. So this will be equal to, when they're subtracted, it's like a division, okay? E to the natural log, or on the top you have natural log of y minus 9, all over natural log of 2, okay? Oh, sorry, so it'd be 1 natural log. Did that make sense?
Yeah, I guess I'd split it. I'd done each one separately.
No, you can't do each one separately.
You can't do
No.
e to the x and e to the.
No. And on the right, we can multiply them. Oh yeah, we should. So e to the natural log of the power of x times natural log of x. Okay? So now we can cancel out the natural, e to the natural log.
Where do you get that second natural log from? You just like-
Oh, no, yeah.
Just like showed it in
But for that part, then you can just leave it like that. So you can just leave it the same thing there. Okay? So then this, if we isolate y is equal to 2 times e to the power of x plus natural log of x plus 9. Or, yeah, the entire thing plus 9.
Their answer was 2x e x, 2 times x raised to the x plus 9. 2x e x plus 9.
E to the x
Yeah.
plus,
No, yeah, well, there's no 9, it's just 2x e to the x plus parentheses. Yes.
That was their answer. So then they simplified. Let me look in my notes. You learn this tomorrow or Monday. Yeah, it's actually new stuff. Oh, yeah. This is equal to e to the x times e to the natural log of x. Does that make sense? When you have, say,
Oh, we multiply. You have to add that. Oh, yes. Oh, we're taking it back.
that's an example of it, or that's exactly how this is. This is e to the x plus e to the net. So when you have two things of the same base with different exponents, you can add the exponents like that.
Yeah.
So this is equal to x. So then this is equal to 2 times x times e to the x plus.
What happens? This canceled. So we're left with. Then we're left with x.
So e to the natural log of x, those goes away. You're just left with an
Then we're
x,
left with x.
and you, yeah.
Oh, yeah.
This is like
Oh, yeah, okay, that's big. Yeah, never mind.
when you, it's a property of exponents.
2x.
The thing to remember is when you do everything, you have to do everything to the power of e. You can't just do them separately. Yep. And you'll learn that on Monday. Or rather, they'll quiz you on Monday, like you know how they do dino summations and stuff.
Yeah, they try to.
Yeah, they'll do that with you guys. So you guys already know how to solve it now. Okay. It'll probably be the same problem. If I have, all right, if I have the natural log of
A lot of this we have just like remembering identity.
Yeah. that is, yeah, it's just there isn't like really hard stuff in this one. Except you have to be careful with the properties that know them. What did I put down? What would it be if I combine them? Y minus 3 over x squared. Got everything here times 3.
It's still in the, it's still with the natural log there, right?
Yeah. Now this one it's yeah, essentially solving for y, but I skipped that part.
Oh, never mind.
Yep. Yeah, you never want to just make it 2x there.
Does it matter?
Yep.
You know, it's the same thing.
The graders will laugh at you.
They don't laugh at it, they'll be like, I don't know. So do like the graders like sit around at like tables like at night and like grade all together your credits?
I've never been a grader, but I would assume that's what they do. Probably not at night, but
I don't know, I just realized when they don't have class.
I mean, they do. They're students.
They don't have class at night.
What?
Like my graders, they just like give out points and like they on the first exam they said like why I missed some problems, but from now it's just like if I miss a problem, nothing.
Yeah.
I write notes to them on my exam, like how we did this wrong because blah blah blah. Or like if they make me multiply something big, like why? It's 8 a.m.
That's like. Let me end this.
Oh.